students, in this lecture we will study about the diagonally dominant form of a matrix. A square matrix A whose elements are Aij is said to be diagonally dominant if the absolute value of diagonal entries, these are the diagonal entries, A11, A22, A33, this is the diagonal. So we represent the diagonal entries as Aii. So the absolute value of these diagonal elements is greater than or equal to the sum of the absolute of remaining entries, and that corresponding row. For example, we see here this 5 is the diagonal entry for first row, and this 5, if you look at this 5 is greater than the sum of 1 and minus 2, the absolute value of these two. The absolute of minus 2 is plus 2, so 1 plus 2 is 3, so the sum of these two is less than this diagonal entry. Or another case, we can say that this diagonal entry is greater than the sum of the rest of these two elements. Similarly, this is the entry and the diagonal for second row, this element. The absolute value of this element is plus 12, and this 12 is greater than the sum of these two. 3 plus 3 is 6, and 12 is greater than 6. Similarly, this is the entry and the third row and the main diagonal, and the absolute value of this diagonal entry is plus 20, and this 20 is greater than the sum of these two. 1 plus 4 is 5, and 20 is greater than 5. So this matrix is now diagonally dominant matrix. Now we have iterative methods, the second methods which we follow to solve the system of linear equations, and these two methods are very important with respect to final examination. The first of these two is Jacobi's method to solve system of linear equations. So what is Jacobi's method? First of all, we need to write the system in diagonally dominant form. The system of equations will be given to us, and we will see that whether the system is in diagonally dominant form or not. If the system is already in diagonally dominant form, then we leave it, but if the system is not in diagonally dominant form, we will write the system in that form. Secondly, we will write the system in iterative form. What does it mean? It means that we should leave the diagonal elements on left hand side, and the rest of the entries should be converted towards right hand side. So this is the iterative form of diagonally dominant matrix. Thirdly, initial guess will be given to us to start from there to perform the first iteration. X0, x1 naught, x2 naught, x3 naught, these will be given to us. And the fourth one is we will continue the process to get the required accuracy. What is the required accuracy? Required accuracy is that if the two consecutive values of xi's are nearly equal to each other, or if the desired decimal places up to the desired decimal places, or it will be given to us to perform few iterations. For example, it will be given to us to perform 4 iterations, 5 iterations, 6 iteration, and so on. So this is Jacobi's method. So let us solve an example by Jacobi's method. The example is in front of us. Solve the system of equations by Jacobi's method using the initial process, initial iteration x0, 0, 0 and 0. So the first equation is given to us 0.1 into x1 plus x2 plus 0.1 into x3 is equal to 2. Second equation is x1 plus 0.1 into x2 is 1.0, and the third equation is 0.1 into x2 plus x3 is equal to 3. We see that this and it is asked that perform 4 iterations, so we need to perform 4 iterations. First of all, we'll see that whether the system is in diagonally dominant form or not. So this is the diagonal x1, then x2, then x3. The coefficient of this diagonal entry, the first one is 0.1. 0.1 is less than the sum of 1 and 0.1. 1 plus 0.1 is 1.1, and this 0.1 is less than the sum of these two. So it means that this system is not in diagonally dominant form. The diagonal entry, the first entry, the coefficient of the first equation will be greater than, should be greater than the sum of the rest of the two coefficients, and the coefficient of the second entry, x2, should be greater than the sum of the rest of the other two, and in the third equation the coefficient of x3 should be greater than the sum of other two coefficients. But this system is not in that form, so we will rewrite the system. You see that the coefficient of x1 is 1 here, and the rest of the coefficients are 0.1 and 0, because x3 is missing here, so the coefficient of x3 is 0 here. 0 plus 0.1 is 0.1, and the coefficient of x1 is 1. 1 is greater than 0.1, so that's why this will be considered as first equation. And secondly, in this equation we see that the coefficient of x2 is 1, and 1 is greater than the sum of these two, so that's why this is the second, this should be considered as second equation. And the third equation is definitely this one. In this third equation we see that the coefficient of x3 is 1, and this one is greater than the sum of the rest of the coefficients. The coefficient of x2 is 0.1, and the coefficient of x1 is 0 here, so this one is greater than 0.1. Now this system is in diagonally dominant form. Now we will write this system in iterative form. What is the iterative form? The iterative form, we need to write this equation, we need to leave this diagonal on left hand side and convert all those elements towards right hand side. So you see, we have converted 0.1 into x2 towards that side, we have converted these two towards that side, and we have converted this 0.1 x2 towards that side. So this is the iterative form of this system. So this is the iterative form of the given system. Now first iteration will be performed by using this initial iteration, x naught is equal to 0 0 0. X naught is equal to 0 0 0 means compare it with the x1 x2 x3 whole transpose, we will get x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0. So put all these values and this system 1 and these equations 1, we will get replacing x2 by 0 here to get the new value of x1 1. Now replace x1 and x3, x1 and x3 in this equation to get the new value of x2, which is 2, and put x2 from here, x2 is equal to 0 in this equation to get the new value of x3. So that is the first iteration. Second iteration will be performed by using the new values of x1, x2 and x3 and the system 1, equations 1. So use the new values of x1, x2, x3 and system of equations 1. So in the first equation, whenever we put x2 by 2, so you'll get the new value of x1 0.8, and the second equation we need to put x1 and x3. x1 is 1 and x3 is 3 to get the new value of x2 as 1.6, and in the third equation put x2 by 2 to get the new value of x3, which is 2.8. so that is the second iteration. And similarly the third iteration will be performed by using the new values of x1, x2, x3. The new values of x1 is 0.8, 1.6 and 2.8. using these values and put these values in a system of equations 1 to get the new values of x1, x2 and x3. so in the first equation x1 is equal to 1 minus 0.1 into x2 and x2 is 1.6 to get the new value of x1, which is 0.86, and the second equation x2 is equal to 2 minus 0.1 into x1 and to x3. x1 is 0.8, x3 is 2.8 to get the new value of x2, which is 1.64, and in the third equation x3 is equal to 3.01 into x2, but x2 is 1.6, so 3 minus 0.16 is 2.84. so these are the new values of x1, x2 and x3. so we need to perform the fourth iteration. The fourth iteration will be performed by using these new values of x1, x2 and x3 and put these values in the system of equations 1. so in the first equation x1 is equal to 1 minus 0.1 into x2, but x2 is 1.64, so the new value of x1 is obtained as 0.836, and in the second equation, that is x2 is equal to 2 minus 0.1 into x1 minus 0.1 into x3, but x1 is 0.84 and x3 is 2.84. calculating this difference to get the new value of x2 is 1.632, and the third one is x3 is equal to 3 minus 0.1 into x2, but x2 is 1.64, and calculating this difference to get the new value of x3. so this is the new value of x3. so that is the fourth iteration, and we were asked to perform 4 iterations. so we have performed 4 iterations. so after 4 iterations x1 is this, x2 is this, and x3 is 2.836. this is the solution regarding Jacobi's iterative method. The process is very simple to understand but very important with respect to examination point of view.